Hello, I am Anushka and today we are going to talk about a very interesting topic, heat of reaction. Let's learn about heat of reactions, which is basically the breaking of bonds. We will learn about energy profiles and also the whole process in detail. So what actually is heat of reaction? Heat of reaction or delta H is the energy needed to break bonds subtracted by the energy released by bond formation. We will take the example of the reaction between methane and oxygen. Let's construct an energy profile. Our reactants are methane and oxygen, and after the reaction occurs, we get the products of carbon dioxide and water. This process is exothermic, that is why energy is released, and the difference, which is clearly shown on this graph, is the heat of reaction. So just to remember, know that energy needed to break bonds subtracted by energy released by bond formation is heat of reaction. Now let's learn about this process in detail. The first step of this process is that the bonds of these compounds will dissociate from each other. The dissociation of bonds requires energy. So we will give some energy to these bonds and then they will become individual atoms such as carbon, 4 atoms of hydrogen and 4 atoms of oxygen. In the next step, all these individual atoms will form different combinations and will give different products. In this process, bond energy is released and 2 molecules of water are formed and 1 molecule of carbon dioxide. So to summarize, first of all, the reactants will dissociate and form individual atoms. This process requires some energy. After that, they will recombine and form new products. In this process, energy is released. The next big question is how to calculate the energy level of reactants and products. For that, we need to know about bond energy. It is measured in kilojoule per mole and these are the examples. As you can see, the single covalent bond of 2 hydrogen atoms bears a bond energy of 436 kilojoule per mole and 2 atoms of oxygen having a double bond bear an energy of 498 kilojoule per mole. You do not need to learn these values because they will all be given in your test. Next, we will have to practice some questions so that you can be confident in solving and calculating the heat of reaction of any given reaction. For the first step, we will have to see the number of bonds present in the reactants and then calculate the bond energy of the reactants. After that, we will calculate the bond energy of the products. As we know, the bond energy of one bond of carbon and hydrogen is 435 and in methane there are 4 bonds present. That is why we will multiply the value of 1 with 4 and get the result. In oxygen, there are 2 bonds present in this reaction, which is why we multiply it by 2 and get the result. For the total energy, we will add both the values of methane and oxygen and record the total value. Now let's calculate for the products. For the products, there are 4 bonds present of water. That is why we multiply it by 4 and get the result. And for carbon dioxide, there are 2 present. That is why we multiply by 2 and get the result. In total energy, we will get the sum total and record it. Now, to calculate the heat of reaction, we will have to calculate the difference between the bond energy required to break the bonds and the bond energy which was released after the reaction took place. That is why we will subtract the bond energy of the reactants with the bond energy of the products and get the answer. As you can see, we got a negative value which tells us this reaction was exothermic as it released energy in the end and the energy of the products was more than the energy of the reactants. To thoroughly understand the whole concept of heat of reaction, we need to know about the process known as activation energy. As you may have listened to me clearly, I stated that if a reaction has to take place, the reactants will first have to dissociate these bonds. But to dissociate these bonds, there is some energy that we will have to apply to these reactants so that the reaction takes place. It doesn't matter if the reaction is endothermic or exothermic, activation energy is important and is needed to start the reaction. When we provide some energy to these reactants, the bonds start breaking and then they dissociate to form individual atoms. which afterwards recombine and form new products. Let's also take an example of the endothermic reaction. In this, there will be a different energy profile. We will take the example of the oxidation of nitrogen, which requires less energy to start the reaction, and will have the heat of reaction in this is increasing, and that is why there will be a positive value when we will calculate it, and in this process energy is absorbed. That is why it is an endothermic reaction. Hence, in an exothermic reaction, the energy of the reactants is much more than the energy of the products, which is why energy is released when they convert from reactants to products, and the value of the delta H is negative. In an endothermic reaction, the energy of the products is much more than the energy of the reactants, which is why the reactants absorb energy to produce the products, and the value of delta H is positive. More clearly, an exothermic reaction has a negative value of the heat of energy, and energy is produced in that reaction. And in an endothermic reaction, there is a positive value of heat of reaction or delta H, and in this process, energy is required. I hope you understand this very difficult yet easy topic very quickly. Happy learning. Thank you. So that's it for today. New videos coming soon. Happy learning.